Hello everyone, I am Amit Gupta. I warmly welcome back to my channel Amit Maths. Here I will discuss class ninth Maths. I see on your screen this is chapter 1 number system. In order to discuss this lecture, first we have to introduce myself. My name is Amit Gupta. I have completed my B.Sc Maths, M.Sc Maths, B.Ed and I have also stated paper 2 qualified. Along with that, I have 3-year teaching experience in these fields of teachings. I have worked as a subject matter expert on Check India Private Limited, where I solve complex mathematical problems and enhance the mathematical skill of the students. My teaching is focused on basic theory concepts and NCERT based and exam oriented patterns. So we will discuss today chapter 1 number system in one shot. So start now. As see on your screens, mm, today our topic is a number system which is for class ninth. Okay, so we will proceed it now. What is a number system? There are four number system here are using as binary system, decimal system, octal system, hexadecimal systems. And binary system are used in computer science and its base is equal to 2 and number varies from 0 1. In binary system only two numbers are used here, 0 and 1. Decimal number means base is equal to 10. Here 0 1 2 3 4 5 6 7 8 and 9. Here 10 number are used for calculation purpose and so operations in these decimal systems. Here because base is 10, 10 number are used here, 0 to 9. Okay. Octal means base is equal to weight. Base is equal to weight. What number uses here? 0, 1, 2, 3, 4, 5, 6 and 7. What is hexadecimal number system? Base is equal to 16. And here number is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 uses as A, B, C, D. Okay, 10, 11, 12, 13, 14 and 15. Okay, 8 rating as 10, B rating as 11, C rating as 12, D rating as 13, E rating as 14 and F rating as 15. Okay, so we can use that in hexadecimal system. So our total focus is on decimal systems. What is a decimal system? You already know that its base is tens and number varies from 0 to 9. This is a decimal number systems we use here. Okay, so we use decimal number system, its base is tens. I hope it is clear to what is the number systems. So these are using computer science. You uh, detail study in your upcoming classes, so we will proceed it. So our topic is decimal number system. So there are some types of the numbers where first is natural number known as a counting number. What is this? This is 1, 2, 3, 4 and so on. And so on means adding 1 you get the next natural numbers. Okay, what is a whole numbers? Whole numbers means including 0 in natural number. Now 0, 1, 2, 3, 4, 5 and so on. This is a whole numbers. Okay, what is integers? If we add whole numbers with negative natural number, it becomes integers. For examples, now this is minus 3, minus 2. It means that here you get, if we add minus 1 in these sides, minus 3 plus minus 1, minus 4, and adding minus 1 in left side, you get next previous numbers of integers, previous negative integers. Minus 1 and this is 0, this is 1 and 2, 3, 4 and so on. Adding 1 you get next number here in the right side, positive integers. Okay, so this is integers number. Okay, and here's minus, this is what? This is known as a negative integer. What? Negative integers. Okay, and here 1, 2, 3, 4 and so on known as a positive integers. Okay, and this is a positive integer, this is negative integer. What is 0? 0 is neither positive nor means neutral integers. This is a neutral integers. Okay, what is a rational number? You say that in any number which can be expressible in the form of p by q, where denominator q not equal to 0 and pq are integers. Pq are integers. Okay, pq are integer. Also p and q in simplest form. P by q in simplest format. Simplest form. It means that their SCF is equal to 1. For example, if we say that this is a 5 by 10, it is not in simplest form, its simplest form is 1 by 2. We can write as also in simplest form, means any number which can be expressed in the form of p by 5 by 10 expressed in the 1 by 2 in the format, so that this is a rational number. If we not expressed in the form of p by q, where uh, they are in simplest form 1 2 and their SCF is equal to 1. Okay, so we can say that this is a rational numbers. And every number which can written above integers whole natural, like 5 can be written as 5 by 1, so this is also a rational number. 0 can be also written as 0 by 1, so 0 is also a rational number. It is clear to you. What is a rational number? What is irrational number? The number which is not rational, which is not rational, which is not a rational, known as irrational. Which is not a rational, known as irrational. Known as irrational. Like what? For example, here you get uh, under root 2, under root 5, pi, okay, and e, etc. are irrational numbers. Topic is come to know that here is that pi, its approx value is 22 by 7. Okay, approx value, not exact value. It means that pi is irrational, but 22 by 7 is rational, because p is equal to 22. This is a integer, 7 equal to integers, q equal to 7, integer not 0, 7 not. This is can be written in the form of p by q. Why? This can be written in the form of p by q. So this is a rational number. Here p is equal to 22 and q is equal to 7, and it's also in simplest form. This is not equal to 0 and both are integer. Hence definition is satisfied. So this is rational. Okay, this is rational, but pi is irrational. It remember you. Okay, and what is a real number? All rational or irrational number known as real number, means every rational or irrational number is real number. So rational or irrational number, either rational or irrational, always real. It means that every number which is written in above are real numbers. Okay, rational or irrational known as real numbers. So we will next diagram. I see on your screens our blueprint for the number system is the familiar about natural whole number, already told you, and the rational number we already told you. The rational number under root 2 pi etc. is the real word magnification, rationalization, the power law. I see on your screens. We will discuss in further and come to the topic, what is expanding our world from quantity to integers. Natural number, as I say, I told you, natural number 1 2 3 and so on represented by set of capital N, whole numbers capital W, including 0 in natural number, integers including in negative integers. Okay, this is here you say that counting numbers starting from 1, this is known as its natural number. Whole number, natural number plus 0, adding 0 is in natural number, you get whole numbers. Integers, all whole numbers plus negative numbers. Integer means all whole numbers and including in negative integers. Okay, negative numbers you get integers. So the only whole number that is not a natural number. 0 is the only whole number which is not a natural number. Okay, but every whole number excepting 0 is a natural number. It is come clear to you. Next, if we are saying this question, this type of questions, every natural number is a whole, then you have to, here you use exam trick is always read the statement backward. If it is works inwards under Venn diagram, it is false. If it works outward, it is true. So this is every natural number is a whole number. So what is this? You say that every whole number is a natural number. It back to the inward. Every whole number is a natural numbers. Okay, what is this? Here you see that every natural number is a whole number. Every natural number is a whole number. You say if inwards, We have to change the colors because this is not visible. If inwards, then false, then false. If outwards, as like that, if outwards, then statement is true. Then statement is true. Here you say that what is say? Here say that every natural number is a whole numbers. We have to come from natural number to whole numbers. Okay, natural number to whole numbers. So natural number here, every natural number is whole number. So this is outward. So this is statement is true. So statement is true because whole numbers include all natural number plus 0. And here it say that every integer is a whole number. Every integer is a whole number. So every integer is a whole number. This is towards inwards. Every integer is a whole numbers. We come to integers to whole numbers. So this is inwards. So this is not true. Here you say that you're taking the example like that integer include negative numbers minus 4, which is not a whole number. So this is false. Okay, and here you see that every rational number is whole number. So coming to the next, this is a part of rational number. This is a part of rational numbers. Okay, this is a rational. Every rational is a what? Whole number. So this is coming to the rational to whole number. So this is coming from inwards. So this is also not true because this is inwards. So this is also false because fraction like 9 by 30, 19 by 30, it is in rational number but not a whole number. You use this as it. Okay. So we will begin the next. What is entering the rational limbs? Theorem box formal definitions. A number is rational if it can be written in the form of p by q. We already told you. P and Q are integer, denominator Q not equal to 0, P and Q are co-prime, means no common factor other than 1. Like here 1 by 2 is as a 2 by 4 is equal to 10 by 20 is equal to 25 by 15 are same rational number because it can be representing as 1 by 2. Okay, and here you see that P by Q is equal to 1 by 2. Here P is equal to 1 and Q is equal to 2 are integer and not equal to 0. Denominator Q not equal to 0 and it have no common factor other than 1. So this is a rational numbers. Means any number which can be expressible in the form of P by Q is known as a rational number and satisfy all the given conditions. So proceed in next. And what is a midpoint method? Here you say that suppose now 3 and 5 are here. We have to find what is the midpoint. Okay, we need to find what is the midpoint. Suppose this is A equal to 3 and this is B equal to 5. We need to find what is a number which exactly come between 3 and 5. So in order to find this, you have to apply this method. C is equal to A plus B by 2. So apply this 3 plus 5 by 2. You get 8 by 2. You get 4. So this is 4. 4 is the number which exactly lies between 3 and 5. So we use that the midpoint method. Okay. Here you say that what is 1 plus 3 by 2. If adding by dividing by 2, you get 5 by 4. As like that 1 plus 3 by 2 upon 2. 2 1 to 5 by 2 upon 2. You get 5 by 4. Okay. So this apply here. And if we want to find the midpoint between 5 by 4 plus 3 by 2, you again 5 plus you again what is this 5 by 4 plus 3 by 2 upon 2. Okay, so you get next number 2. What is LCM is equal to 4. 5 1 ja 5 plus 3 2 ja 6 2 2 ja 4. So 6 upon 2. This is you get 11 by 8. You get next number between them. If you want to again next apply this here, so it will calculate, but you will find the number between two given number. Okay, midpoint. Okay, this is formula using here. But in the NCERT says what? For example, if you have to find four rational number between 3 and 4. Okay, if we applying this theorem, so it might be calculated, but in NCERT says that if you have to find 4 na, you multiplied 4 plus 1, this is equal to 5. If you multiplied in both, so solution is that we multiply 3 and here is 4. Okay, and multiplied by 5 upon 5. So it can be not changed. 5 by 5 is equal to 1. So there is no effect in the value in 3. This is 15 by 5 and multiplied here 5 by 5 you get 20 by 5, and 25 by 5 is less than 16 by 5. This is 17 by 5 greater than 16 by 5. 18 by 5 is greater than 17 by 5, and 19 by 5 is greater than 18 by 5, and 19 by 20 by 5 is greater than 95. You get what? 1 2 3 4 4 numbers you get here. You get 4 numbers between 3 and 4 using NCERT method. What you simply apply it, if a question is such, you have to find 4 decimal number, you have to uh, adding 1 in the what number find you. Okay, like 4 plus 1 we multiplied numerator and denominator as 5, and here we numerator and denominator 5, you get 4 numbers. This concept is used here. Okay, I hope you understand it. So this topic is that, remember that but remember you that there are infinitely many rational number between any two given rational number. Okay, it means that on number line representation, you say that if any numbers, like for example here, suppose 1 and 2, every point represent a rational number. So if here there are infinitely large many points between 1 and 2, so we can say that there are infinite number of lies between 1 and 2. Okay, but as similarly 3 and 4, similarly like 3 and 4, any two rational number, they are infinitely rational number, infinitely irrational number. So we already told you. Next, what is that? Decimal expansion of real number. It means that terminating decimal expansion of real number, terminating and non-terminating. Okay, terminating means after dividing it terminate, as like 1 by 2. If 1 by 2 divided by this, you get 0.5. The decimal expansion ended at after 1 decimal place is known as a terminating. For example, 1 by 3, if you divide 3 in 1, you get always 0.33333 and so on. Okay, so this will be repeated so many times. This is can be 0.3 bar. 1 by 3 representing a 0.3 bar. Okay, so this is known as non-terminating and repeating are recurring. Here you see that 1 by 3 is equal to 0.333 and so on. 14 by 11 similarly 1.272727. So it can be also written as 1.27 bar. Okay, this is known as a repeating decimal number. Okay, like 5 by 2 is what? 2.5. After some decimal it breaks, so it is a terminating. Okay, I hope it is clear. And by what is non-recurring means no pattern. We cannot use in the format of bar, like pi is equal to 3.14159 and so on. It cannot be used as a bar format. Root 2 equal to 1.414. We use approx value of the irrational number always in calculations. I hope it is clear to you. Next topic is what? Reverse engineer decimal back to p by q format. Now suppose this is x equal to 1.99. It's so multiplied 10x is equal to 19.99 and so on. Subtract equation 1 from equation 2. This is 10x equal to x 19.999 and this is x, and subtracting from them you get 10x minus x 9x 99.9999 cancel out 0 and 19 minus 1 is equal to 80. 9x is equal to 80. You get x equal to 2. Did you just prove that 1.9 is exactly equal to 2? Yes, the math does not lie. Okay, you did, because you say that if any number like 1.9 bar, this is equal to 2, because we use a 1.9 bar as a 2, because there is 1.999999 and so on and 2. There is no number lies between 1.9999 and so on, between just saying that it is converses to 2. So that you already find it. 1.9 bar is equal to 2. Okay, so I hope you understand it. If you say 1.39 bar is just equal to 1.4, because there is no number lies between 1.39 bar and 1.4. Okay, it is approaches to 1.4. I hope it is clear to you. Next topic is what? Real numbers. Real number is breakdown in rational and irrational numbers. Okay, Like rational numbers cannot be written in the form of p as p by q. Their decimal exponential is non-terminating and non-recurring. For example, rational, you say that it is td terminating decimal number या NTRD non-terminating repeating या recurring decimal numbers. Like it can be written as 5 by 2. This is 2.5. Decimal expansion is 1.3 bar or 0.3 bar, 1.42 bar. Okay, NTRD means non-terminating but repeating. But irrational number is look like as 1.01, 001, 0001, and so on. It cannot be used in the format of bar. So this is not a rational number. Okay, I hope it is clear too. It is non-terminating and non-recurring, means non-repeating. Okay, so we can non-repeating sense we cannot use in the format of bar. Okay, so we proceed next. Prove by contradiction. Assume the opposite root 2 is rational. Contradictions, using contradiction to prove under root 2 is irrational. Here you say apply this concept and use it use in class 10th. So we will discuss in the next lecture here, so we can proceed it again. What is how to visualize under root 5 on the number line? So you have to understand the concept is what is here. So we use in add slide to understand these topics. Use the slide as see on your screens. This is a right angle triangle. Okay, this is a right angle triangle. This is a right angle triangle as see on your figure ABC. Okay, if we say these angles, taking this angle, you get its opposite side is perpendicular. Perpendicular stand for P. Okay, and this is a base, stand like capital B, and this is a hypotenuse. Hypotenuse. Okay, standing as H. Pythagoras theorem here is what? Pythagoras theorem. Pythagoras theorem says that hypotenuse square is equal to perpendicular square plus base square. This is a this is a Pythagoras theorem. Okay, and this is a Pythagoras theorem. If you have to represent irrational number on number line, what concept we use? Like representation of under root 2, under root 3, under root 5 on number line. What we do? Okay, so in order to do, we first draw a number line as like that, and scale using 1 centimeter is equal to 1 unit. Okay, so we measure as 1 centimeter, taking a point P, measure 1 centimeter. Okay, and here also 1 centimeter, so 1 unit. So this is 1 centimeter, this is 1 centimeter, 1 unit. So what is this? What is this? So this is the length. So this length, it is taking as a right angle triangle. What is this? Is H. Okay, what is H? H is square is equal to 1 square plus 1 square becomes right angle triangle. We use H. So H is equal to under root 2. 1 plus 1 2 and square, taking square root both side, you get H equal to root 2. So this is H root 2, and using the compass, one needle is here and second needle is here. You get as like cutting the by compass, you get this, and this point is what? This point is under root 2. Okay, if you representing under root 3, you again again taking 1 unit here, and this line representing what? This line represent, and taking this taking the compass and taking needle at the point, and second needle here, and cut this axis, you get here under root 3. Okay, under root 3. So apply this, you get any root 2, root 3, root 5 here, you get this. Here concept is using here. As the spiral root is spiral is here. Okay. And what is this? We can build any rational number root by the previous root as our base. Now root 2, in order to find root 2, we cannot find just like root 5 in one shot. We use root 2, root 3, root 4, root 5, we go again proceed in next. Okay, like example like here, if you getting under root 2 and taking 1 in this you get under root 2 here. In order to find under root 3, just under root 2 is here, apply 1 unit here. Okay, applying 1 unit here, you get 1 unit. This is taking like here, so you get under root 3. So if you apply under root 2 here, under root 2 and taking 1 here, okay, and you get under root 3 as like here. So what is this? This is a base. Suppose this is a base, this is a perpendicular, and you apply the Pythagoras theorem, h equal to under root p square plus b square, and apply it. Here you get what is p square means 1 and b square means 2. You get under root 3 as like that. What? And taking under root 3 you get. Then after apply under root 5, under root 5, and taking under root 2 here, and apply this using by compass, taking this length and a perpendicular from along this, you get under root 5. Okay, I hope it is clear to you. In order to find under root 5, you plus root 2 and root 3, then after root 5. Okay, I hope it is clear to you. Successive magnification locating 3.765. This is first. In first you get, you always know this is lies between 3 and 4. So applying this here 3 and 4. In next concept, you say that here you see that after some decimal there is 3 points here. So we use in 4 method. Here first is finding the integer in which integer they are like 3 and 4, and second is this 3.7. These are line 3.7 and 3.8. Okay, so we use 3.7 and 3.8. In second method we use 3.76. So it is lies between 3.76 and 3.77. You get this. Okay, in next you get 3.765. thus it lies between 3.764 and 3.766, just lies between there. So this is here 3.765. it is lies between 3.764 and 3.776. I hope it is clear to you. And we will be coming to the next topic is here, when worlds collide operation on real numbers. You see that rational plus minus irrational, you get always irrational numbers. Okay, if you say that if we add any rational number to irrational number, yeah, we subtract rational minus irrational, you always get irrational. Okay, yes. And if you multiply rational into irrational or divide irrational, you always get irrational, provided you already know that irrational rational not equal to 0. If rational not equal to 0. Okay, coming to the, if rational 0, if you taking rational 0 and 0 into irrational, always get rational. Okay, but here you say that simplify that rational not equal to 0 means non-zero rational. If you multiply it by non-zero rational and irrational or divide it, you always get irrational number. It is clear to rational not equal to 0. Okay, if irrational plus irrational, you always, it can be rational or irrational. For examples, like suppose 2 plus under root 3 is irrational and 2 minus under root 3 is irrational, and plus root 3 cancel out, this is a 4, this is irrational. Okay, and now root 2 irrational, root 3 irrational, so root 2 plus root 3 is irrational. Similarly using in subtractions, also multiplications and divisions. Okay, so if irrational plus irrational may be rational or irrational, irrational minus irrational may be rational or irrational, irrational into irrational may be rational or irrational, irrational division irrational may be rational or irrational. Okay, here you see that 3 plus 20 root 3 minus 20 root 3, you get 3, but both are irrational, you get rational. In case root 2 into root 3, you get root 6 irrational, because root 2 and root 3 are irrational. So we can say that this rule apply here. I hope it is clear to you. Coming to the next point, rationalizing. 1 by root 2. Rationalizing 1 by root 2, it means that we have to divide under root 2 from both numerator and denominator. So 1 by root 2, it can be written as here. We can representing it under root 2 by under root 2. This is becomes under root 2 by under root 2 becomes 2. So this is here. And rationalizing 2 root 7 by 7 root 7, here you get that 7 root 7, and rationalizing root 7 is equal to become 7 7, 2 7 ja 14 and 2 7 7 7 ja 49. ऐसे it can be 7 2 ja 14 and 7 7 ja 49. So 2 by 7 is our correct answer. Okay. Why do we do this? To remove square root from the denominator, making calculation and number line plotting infinitely easier. So this is the reason I have to remove the uh, irrational number from the denominators. So this is using here. So what is this? And the exponent dashboard large. Okay, large of powers. First law is that product law. A ki power m into a ki power n. If base is same, then here you have to focus on base is a. Here be base is a. If you say 2 the power 3 and 2 the power 4, you simply add 2 the power 3 plus 4. You get 2 the power 7. If you say 2 the power 3 and 3 ki power 2, you cannot able to add as like 2 ki power 3 plus 2 or 3 ki power 3 plus 2. Okay, base is same here, a. Add exponent when multiplying. Here you say the quotient law. A ki power m upon a ki power n is equal to a ki power m minus n. Okay, here you same base here. Okay, so this is also applicable here. Power of a power, it means that a ki power m to the power n is equal to a to the power mn. For example, you say if 2 the power 3 is equal to 4, similarly you writing as 2 raised to the power 3 into 1 to the power 12. Okay, this is used as it. Now a into b to the power n is equal to a to the power n into b to the power n. This is the product, power of a product. Okay, power of fraction. A by b to the power n is equal to a to the power n upon b to the power n. Okay, so simplifying as that. Now this is what add exponents when multiply. Algebraic meaning here is that subtract exponent when dividing. Its algebraic meaning here. A to the power m to the power multiply exponent. Base is same. Distribute power to factors. Distribute power to the factors and multiplying them. Distribute power to the numerator and denominator here. Okay. Here a applied examples is that 4b and 3b to the power 5. Okay. Here you say that 4b is here. 4b is here and here 3 ki power 5 and b to the power 5. B ki power 1 plus b ki power 5. B ki power 6 and multiply 4 into 3 ki power 5, you get 972, b to the power 6. Here a by 5 is equal to what? Using as a ki power 5 minus 2, you get a ki power 3. Okay, here is what? Applying this concept, this is 2 the power 2 and x to the power 3 to the power 2. And applying it, you get 2 the power 2 into x to the power 6. You get 4 into x to the power 6. So here is here. X into y whole square, x square into y square, x upon y ka whole square is equal to x square by y square. Here condition is that base a is real number and m and n are rational numbers. Okay, it is only applicable here. What is condition? Condition noting point is here. A is real number and m and n are rational number. Okay, it is clear to me. Coming to the next point. Here is that dealing with the unconventional and negative fractional powers, the zero power. If it rating as a to the power 0 is always equal to 1 provided a not equal to 0. It means that you cannot able to say 0 to the power 0 is equal to 1. This is indeterminate form. Indeterminate form. Okay, we cannot able to say here indeterminate form. So a not non-zero. A should be non-zero. Means 2 to the power 0 is equal to 1. Yes. 5 to the power 0 is equal to 1. Yes. 1 by 2 to the power 0 is equal to 1. Yes. Okay. Number is not 0. Non-zero. Okay. Simply a to the power m upon a to the power m is equal to what? A ki power m minus m. A to the power 0 is equal to 1. Proof. Okay. Here the negative power a to the power minus n each can be written 1 by a to the power n. For example, 10 into q ki power minus 2 is equal to 10 upon q ki power 2. Okay, so this is here. You cannot able to write as 1 by 10 ki power q square. You already know that. A to the power m by n can be written as, here you see that if nth root of a can be written as a to the power 1 by n. Here applying here a to the power 1 by here a ke power m by n we can written as a to the power m to the power 1 by n. Okay, so apply here and at root of a to the power m. So this will be can written as here minus 2 raised to the power 1 by 2 represent square root of a negative number. This is not a real number. It can be simplified as this. Okay, so this is not a real number. It is not a real number. It is a complex number. We will discuss in class 11. Okay, so we will discuss in class 11. This is not a real number. Next concept is that apply and master exponent exams. 256 raised to the power 0.16, 256 raised to the power 0.09. Applying this concept here, a to the power m into a to the power n is equal to a to the power m plus n. Applying here 0.16, 0.09. Adding this power, base is same 256, 256. So power is adding 256 raised to the power 0.25. And you know that 0.25 can be written as 1 by 4. So applying here, so 256 raised to the power 1 by 4. And you already know that 4 to the power 4 is equal to 256. By what? 4 ke power 4 can be written as 4 into 4 ke power 2 into 4 ke power 2, 4 ke power 2, 16, 16. 16 square is equal to 256. So applying it here, so 4 to the power 4, it can be written as 4 to the power 4 to the power 1 by 4. And applying the power rule, this is can be written 4 into 4 ke power 1 by 4. 4 cancel out, this 4 to the power 1, this is equal to 4. So final answer is equal to 4. I hope it is clear to you. Next is what? Here some students might be confusing there. A plus b whole square written as a square plus 2ab plus b square. But some of student and writing is here a square plus b square. This is a common mistake. We cannot use as, okay. Plus 2ab terms is not here. So if we add in 2ab, then we get a plus b whole square equal to a square plus b square plus 2ab. Okay. So here missing the term is 2ab. It is mistake 1. Okay. Never distribute exponent over additions here. Mistake 2. Don't leave it infinite. It simplify to under root 42. If we saying that under root 12 and under root 3 is a rational or irrational, some students are saying that this is not in the format of b. But definition is that we have if any number which can be expressed in the form of p by q, so it can be simplified here. It can be written as under root 12 by 3, 3 4 is 12. Now you get 4 and under root 4 is equal to 2. It is a rational number. Okay, so simplify it. Just don't leave it infinite. Simplify to under root 4 2, which is rational. So simplify it. Without simplified, we cannot able to say this is number what? Rational or irrational. Mistake 1. What is 0? 0 can be written as 0 by 1, so it is rational. 0 is not rational, it is mistake 3. Okay, and mistake 4 is that skipping construction asks when plotting root 5, you just mark the line without showing the compass arc, you lose marks. I told you already how to represent under root 5 on number lines. This concept is saying here. Some important step marks are awarded even if your final calculation is wrong. Showing the correct formula intermediate step guarantee partial credit. It means that if you solve some question as like that, you and which question is solved in 5 steps, your 2 step is incorrect but last 3 step is correct, you got some marks. Okay, so don't skip it. If you know 3 step, you apply in your handwriting, so you get some marks in correct step. Okay, so this is the credit systems. Self-assessment of important board pattern questions, you have to simplify it. It can be written as in the form of what? 81 raised to the power 0.16 plus 0.09. So this can be written as what? 81 to the power 0.25. 81 can be written as 3 ke power 4, and this is 1 by 4. 3 ke power 4 into 1 by 4, you get what? 3 ke power 1, you get 3. And simplifying it, you get 0.3333 and so on is equal to 1 by 3. I hope it is clear to you. Locate under root 2 on number line, full geometric construction. I told you, you will get. If x is rational and y is irrational, x, y necessarily irrational, prove with example. Suppose 2 is rational and root 3 is irrational, you get 2 into root 3. 2 into root 3 what? Irrational. Always irrational. Okay, this is always irrational. It is true or not? Not true, because if we saying x equal to 0 and y equal to root 3, you get 0 into root 3, and 0 into root 3 0, and b it becomes rational, so b it can necessarily irrational. No, answer is no, because if we taking 0 as a rational and y equal to 1 root 3, you get 0 is rational. So this is not true. Prove with example. It can be proved for the examples. So maybe rational or rational. If we saying x is non-zero rational, so we can say that x into y is irrational. Okay, I hope it is clear to you, and you can check it from your sites. Okay, and solve these concepts. Complete ultimate formula, I have to revise here. Real numbers representing by R, rational number represented by Q, integer represented by set of capital Z, whole number represented by capital W, natural number is capital N. Large of exponent, I told you, a to the power m into a to the power n is equal to a to the power m plus n. Product rule, a to the power m to the power n, a to the power m, and power of a power, a to the power m upon a to the power n, a to the power m minus n. Quotient formula, a into b to the power n, a to the power n into b to the power of a product, a by b to the power n is equal to a to the power n upon b to the power n, power of quotient. And p by q conversion 0.33 bar, x equal to 1 by 3. Okay, so here decimal expansion is terminating rational, non-terminating rational, non-terminating non-repeating irrational number. I hope it is clear to you. If you have any query related to number system, please comment in comment box. I will provide in next video. Thank you. Jai Hind.